So, hello everyone. Thank you for joining this webinar. My name is Tim Rotak from the product marketing team. With me, I have Matt Groves, and we are going to talk about Couchbase versus MongoDB and try and give you a solid overview across a wide variety of topics. So in terms of the agenda, what we're going to talk about is building modern applications, cover that briefly and what that entails and how we think about that. We're going to talk about the product similarities between Couchbase and MongoDB, and also then highlight several differences that we think are quite relevant. And then we'll sum up and give you some maybe things you could do next or more information that you might find interesting. So modern applications. So when we talk to our customers and ask them about how they're building applications, we get a lot of feedback about how much things have rapidly changed in the past 10 years, right? It's really about the driving great experiences for a huge number of users, doing that in a flexible way, deploying effectively, and all of those need to be powered by a flexible, powerful database behind the scenes. It really needs to match the application goals and the development challenges of our customers. And along that line, Couchbase and MongoDB fit into that category, supporting those types of applications. Both of us as organizations are used across many different industries and a lot of different verticals. So you can just see a snippet of them here. And we'll dig more into some of these use cases as we go along through the presentation. And so at this point, I want to talk to you a little bit more about the similarities, right? Because in supporting those different use cases and those different verticals, there are some significant aspects of MongoDB and Couchbase that are similar. So let's highlight those first, right? First, both platforms are distributed NoSQL databases, right? And that means we're providing flexibility in the JSON document storage mechanism that we use, flexibility in schema. And that means in terms of developing applications, you get a lot more rapid ability to build applications versus compared to a traditional relational database. But we've also had a very different focus. So Mongo for the past, let's say, 5+ years has been very focused on developers. How can they grow, be useful to a lot of small developers, individual developers, students, and organizations as well, but really trying to be a broad starting place for lots of different use cases. They were very early to cloud database as a service, several years ahead of Couchbase, and it's a very popular database. It's used, as we know, by many people around the globe. Couchbase has had a little bit different strategy, I would say, in terms of ensuring that our customers have the flexibility of a NoSQL database, but the familiarity of SQL coming from that relational world. Critical to Couchbase is performance at scale with in-memory speeds for high availability for critical applications. But that can be for enterprises. We have very large customers, but also startups too. We have a lot of customers, 25, 50, 100 people, and we'll talk to you about some of those customer examples as we go forward. So building upon the flexibility, right? So at the core of both Mongo and Couchbase is the JSON document or document databases, which are great for applications in the ability to change the data. And so that's good for the application and the developer supporting agile development, things like that. And especially in particular use cases, things like user profiles and product catalogs and things like this, where you want a lot of similar data close to each other, so it's not spread across different tables, right? And so you can kind of see that scenario here in this user profile. Likewise, both databases are what we call multi-purpose. You may have heard of multi-model. And essentially, this means that we can support different use cases and different workloads for different microservices or wwithin larger applications, depending upon the need of those applications. And if we look at the Couchbase platform, we highlight kind of the core capabilities that our customers are building their applications on top of Couchbase with. The first kind of ones we highlight is an integrated cache, key value access, and JSON documents. In fact, Couchbase was over a decade ago the merger between two technologies, a document database and a caching technology. So that's really at the heart of what we do, but supporting things like ACID transactions, SQL, and so forth. And Mongo can do a lot of these different things as well. Some of them in a more limited way than Couchbase, and we'll highlight those when we get into the differences area. But we like to talk about Couchbase as fast, affordable, versatile, and easy, and calling out a few different areas where we think we stand out relative to MongoDB. I mentioned database as a service. So both companies have database as a service, right? It really helps small teams, individual developers, or larger organizations that are just trying to reduce their administrative burdens on managing a database, right? So we both have that. Both are available on all three clouds. Both are supported in over 75 cloud regions. We both have a free tier for developers. So developers can come and use Couchbase, Capella, our database as a service for free. And we both have low-cost options to start. So there's a lot of similarities there. Okay. At this point, we're going to talk about, we're going to do a quick demo called What is this thing? And so we're going to hand it over to Matt.
Please.
I've got to stop sharing.
Yes, and I will share my screen. Thank you, Tim. So I want to show this demo. It's running on Couchbase as the backend database, and it kind of shows the multi-purpose nature of Couchbase, which Tim just touched on there. The source code is available on GitHub if you want to try it yourself, but this is a demo e-commerce site. So in this system, there are a number of stores, store locations. Each of these stores corresponds to a latitude, longitude point on the map, and each store can have in-stock items. Now, what kind of items? Well, let's browse the catalog here. There are some real items here, like this Couchbase swag, and there are some made-up items here with images generated by AI, just for fun. Each item has a name, description, price, and rating. The browser has my current location, so if I look at the pickup options, I can see here that it's going to check the 3 closest stores to me to see if any of these items are in stock nearby. So you can see that 2 places close to me have this cryogenic coupler in stock. And if it's not in stock, then like for instance, this carabiner, I can just get delivery only. So no stores near me in Ohio have the Couchbase carabiner in stock. I can also filter by price. So for instance, I can say maximum price of $50 and rating, say 4 stars and up, just like a normal e-commerce site. So this is all the items that are under $50 and filtered to 4 stars or more. So let's look at this Couchbase pen. Specifically, it's a black pen, got a Couchbase logo on it, and I can add this to my cart if I want to. So that's now in my cart right there, Couchbase pen. And if I go to the top right here, I can click on SQL++, and I can see the actual SQL code that's being used to generate these results. So Couchbase is a JSON document database, but as Tim mentioned, we have full SQL capabilities. But I want to focus on the multi-purpose nature of this query. So I can copy and paste this right into Couchbase Capella if I wanted to. But note that it's combining this portion here is geospatial search. So it's using my latitude, longitude with a common table expression, a CTE, and then just a regular SQL query here to project all those items. There's a subquery to get the stock from nearby locations. And then here's the filters down here for the price and the star ratings, ordering and paging with limit and offset. This is all in a single query. Now, hypothetically, this query could also have time series elements. It does have some key value to an extent, but we could have more key value elements. We could use user-defined functions, text-based search, or vector search, along with managed caching is just built into Couchbase. It's all in one query. And this is called hybrid search. And that's what I wanted to show with this demo here. Now, in fact, let's check out how you might want to use vector search as well. So each of these items have an image, and these in the data have been embedded with a vector from an image model. In my case, it's Azure Computer Vision, but it doesn't really matter as long as it has a vector, work with any sort of vector. So suppose you had a e-commerce site for your parts store, your hardware store. Your customer has a part in hand that they want to replace, but they don't exactly know what it's called. In fact, one of our coworkers just approached us and says, "My wife sent me this picture, and she says this needs replaced. I don't have no idea what it is, or what it's called, or where to get it." So, and this happens to me all the time too, because I guess my stuff just breaks all the time. I want to know what this part is so I can replace it. So that's the main part of this demo, is the what is this thing. So I can upload an image. I've got some standby images here, but I've got a picture of this Bic pen. It's a clear pen with blue ink, and it's got a cap. So I've got a picture of that at a different angle than my Couchbase pen with the cap taken off. So I'll go ahead and just upload that image. If I'm on a mobile browser, I could take a photo with my mobile phone. So it comes up here and says, well, the most likely match is this Couchbase pen. It's the closest thing I could find in my catalog to that. So maybe you want to get a Couchbase pen instead of the generic Bic pen there. So when I upload this image, it was actually run through that same Azure computer vision model to generate a vector. And that vector was used in a nearest neighbor search. So we can actually see the code for this again in the demo. So very similar, the CTE with geospatial, the subquery. But now here's the vector search part. So it's a nearest neighbor search right there. And here's the vector that was generated from that Bic pen image that I uploaded. And it's getting the 4 closest items based on this vector. So the closest match was the pen. There's some other items that are kind of close, but as you can see, the scores aren't nearly as good for that one. So we have one query that contains geospatial, SQL query with joins, filters, subquery, and nearest neighbor vector search, all in one set of data, one database, one query. So multi-purpose access to that same data pool is one of the key benefits of Couchbase. So no need to duplicate between different data tools. You do all those things, as well as analytics and mobile, as we're going to see going forward in this webcast. So I'm going to hand it back over to Tim.
Great. Thanks, Matt. Let's see here. Oh, sorry, double clicked. All right. So we talked about some of the similarities between ourselves and MongoDB, but let's highlight some of those differences, right? And so we've got a couple different topics we're going to cover. We're going to talk about data organization, our query language. We're going to hit on Couchbase Mobile and data synchronization, architecture, and analytics with our Capella columnar. So if we go into data organization, so in some ways, being document databases, there is some similarity in that, we both have document structures, and MongoDB stores them within collections, which are within, the broader database category. Couchbase, on the other hand, though, we've added a second logical layer in there called scopes. So you can see here that our bucket layer, which is like a database, has scopes, collections, and documents within it, which lines up really nicely with a relational model. And that has several advantages here. One is in terms of, let's say you are trying to map let's say a more traditional relational application into this new, NoSQL world. Well, this makes that a lot easier. In terms of things like multi-tenant environments, if you wanted to do that, having that extra layer makes building for ISVs, multi-tenant applications, a bit easier. As well as then you have a lot more control in terms of things like replication, in terms of user access, indexing, and so on, to be more finite in how you define things. And that can help with performance as well, right? So that was the first topic, data organization. It's kind of short, but that's fine. The next topic is query language. So we're going to talk about SQL++. So what is that? Matt, I think, referred to it earlier. Essentially, SQL++ is an extension of SQL specifically for JSON data. It's something that Couchbase has implemented, I want to say, roughly a decade ago, and it's now used by other NoSQL vendors as well. And you can see an example on the right. It looks very much like traditional SQL, but designed for JSON documents. And in fact, SQL++ meets ANSI standards, right? Supports that, but it's also very powerful in supporting joins and arrays, user-defined functions and things like this. So you can build very complex or sophisticated queries with SQL++. And it has the benefit that it's pretty well understood, right? It's been around the database market for decades. And why does it matter, right? So MongoDB has MQL, which is their proprietary query language. And here you can see two examples of what are essentially the same query: SQL++ on the left and Mongo's query on the right. The SQL query is clearly easier to read and easier to figure out, especially when you have people troubleshooting queries or looking at something for the first time. Additionally, SQL++ is a declarative language, meaning that it's easier in terms of you're just defining what you're looking for, whereas MQL is imperative, meaning you have to define what you're looking for and also how to get it, right? So that adds a level of complexity. And in terms of, what do our customers think about SQL++? Well, in surveys we've done of, why customers have, chosen Couchbase over MongoDB, SQL is listed as, the most common or their favorite reason for picking us versus them. And then here's a nice little quote from one of our customers in terms of, his perception, his appreciation for what Couchbase has done with SQL and SQL++ in terms of working with JSON documents. Okay, let's move on to our third topic of things that are different from Couchbase and Mongo, which is mobile. And if you are using MongoDB for mobile, or maybe you're just familiar with it, you know that Mongo acquired Realm for their mobile offering, I want to say about 6 years ago. And it just, in conversations with different customers who worked in that environment, we've always heard kind of, let's say, grumblings of the way that it was integrated or not being as integrated as it should be. So there's always been some challenges there. And recently, Mongo has announced an end of life for their data sync. So they've decided at this point that this is not something that they want to pursue. And so customers have till the end of September of next year to stop using that product. So we could really do a very, could have in the past done a comparison apples to oranges or apples to apples, but I don't really think it makes a lot of sense in this scenario because Realm is going away. So we're going to just cover a little bit of Couchbase Mobile and give you some insight into how it works and some of its capabilities, right? So Couchbase Mobile, 3 foundational elements to it: the backend database, Couchbase Capella, our database as a service; Couchbase Lite, the embeddable database that goes into the mobile or IoT device. And then the magic happens with the synchronization in between in terms of app services, where that's controlling the data flow, user access control, authentication, things like that. And we'll get into more detail. Now, this can be run in a self-managed environment, but we're seeing more and more customers moving to the database as a service. So who's using Couchbase Mobile? I won't go into all of these use cases, but we do have customers like Pepsi who've been using Couchbase Mobile for many, many years. And we've got smaller startups, as I mentioned at the beginning, people like Quantic, which is an organization of around 50 users. They build their application for their clients as a point of sale system that has Couchbase Lite embedded into it. They want their information to work even if the internet goes down, right? The connectivity goes down. They can't have a point of sale system that stops working. Lodem is another customer also around that kind of 50 user mark. They're a gaming company, and they embed Couchbase Lite into their product, and that game has been downloaded hundreds of millions of times. So in terms of like scalability, and they're using Capella database as a service to manage that aspect of their application. Okay, so let's look at it from a bit of an architecture standpoint, and we'll also play a little bit of an AI angle that Matt had shown in his demo as well, right? So what does this look like? Well, first from an AI standpoint, so whether a customer is looking to build AI into their application in the cloud or on device, Couchbase can support you. Couchbase Mobile and Couchbase were the first to have vector search support both in cloud, on-prem, and mobile. Right, so really letting customers have a lot of flexibility in terms of how they build their AI applications. And in this scenario here, what you see is, you have the backend cloud database, which can be fully managed or server, right? that can sit at the cloud or edge layer. So one example from the previous slide was a mobile company. Was a medical company that builds Couchbase Lite into their medical equipment, and they have an edge server within the medical facilities, right? So they can do data synchronization from the cloud to the medical facility and down to the actual device. And we'll support vector search and hybrid search like Matt showed earlier, but also popular AI frameworks like RAG for building out chatbots. And so I'm going to show you just a quick little demo similar to what Matt showed. Let me go here. And what you're going to see here is a little application that we built. I'll just click on a video real quick.
That is, I think he's back. Yeah, so you lost your audio during the video there, Tim.
Oh, can you hear me now?
Yes.
Great. Okay, sorry about that. So we'll wrap up real quickly with Couchbase Lite and Couchbase Mobile. So very sophisticated, powerful offering, broad support for different use cases, technologies, and for those who are coming from the Realm world and looking to make a change and wondering, how might I do that? What would really be the steps? One of our colleagues recently recorded a video. The link is here. It's also at the end of the deck on how you might plan that, how you might think about it, and what the steps might be to go forward if you want to move that direction. Okay. Now, our fourth topic on kind of differences. We're going to talk about high-speed architecture. And when I think about architecture and delivering high speed, they're kind of two areas. It's really about performance and memory management, and then the ability to continue to do that at scale. So if we talk about performance, what does that mean? Well, it's really about how quickly can the database read and write, and the low latency that it provides in delivering that. And then, so how do we measure that, right? It's classically benchmarks. And for NoSQL databases, YCSB is the standard for measuring database benchmarking. And so what I'm showing you here is there's a website that you can go to, and there's a link again at the back of this deck called Benchant. They're a third party that does independent benchmarking of databases. And what you're looking at here is they have put together a ranking where they've done across different configurations, across different clouds, I think 6 or 7 different NoSQL databases. There's like 150 or 200 different configurations in that ranking. And you can see that currently Couchbase is at the top of that list. And in the fact, we're at 6 of the top 10 slots held by the Benchant organization. MongoDB's highest rank is 41 in this ranking. And it's for a scenario on Alibaba Cloud, where it's Community Edition, their large scenario. And you can see here with Couchbase in a very similar configuration, we're approximately 6 times faster. But Mongo just announced version 8. So how might that come into play, right? Does it, what's the latest on that? So recently, within the past couple of weeks, we've run our own benchmarks internally, and we actually have an interesting webinar that Matt was a part of, talking about how you might run benchmarks, what are tools you can use to run benchmarks. So we'd encourage you to always, do this yourself, look at, your own configuration and your own scenarios. But this is something that we recently ran looking at a 3-node system on AWS for both us and Mongo Atlas. And this was used against their version 8, so their newest release. And you can see across almost every single workload here that Couchbase Capella is still far ahead in terms of performance and throughput. Okay. One other thing to mention about BenchAnt is in addition to the ranking of benchmarks that they do, they have a separate offering that they do called the database DBAS Navigator. Essentially, in addition to performance, what they do is they look at DBAS offerings across a wide variety of categories. You can go and explore this and get more information to see how Capella compares to Mongo Atlas. Okay. So how do we achieve this? How do we achieve this speed, right? I mentioned at the beginning that Couchbase was formed as a merger between a document database and a caching technology, right? And that really comes into our memory first architecture, the ability to, as we move data, things are happening first in memory versus before we are writing to disk, and that is happening both within the cluster. So the way we move data with our data change protocol between different services and between different nodes, but also between clusters. That is also happening in memory. And if we look at that a little bit further, what's another aspect of this, right? I mentioned the memory first nature of this, but also then when we look at it from an application interacting with Couchbase, right? Our SDKs, which get built into the application, have what we refer to as the cluster map. And the cluster map really is really responsible for identifying exactly where the data is on or within the Couchbase cluster. So the application, as KV operations are happening, or queries are happening, are going directly to the right source to get that data. Additionally, all nodes within Couchbase are active, meaning that every single node can read and write, which is also helping from a performance standpoint. Well, what does this look like for Mongo, right? So for Mongo, it's a little bit different. There's additional steps and processes in terms of how the data is retrieved. First thing to note is that, like in a 3-node cluster, only one of those nodes is active, doing read and write. The other two there's primary and then secondary, so the secondary wouldn't be able to write. But in addition to the data routing and getting at the data, it needs to go through different routers called Mongos or MongoS, and also configuration servers. And so essentially, those extra hops are requiring extra time, extra processing power, which isn't the best in terms of overall performance. And we see that in the numbers, right? A little bit deeper in terms of, let's say, how RAM is used, for example. So here's just a small model of 3 different nodes within Capella and within Atlas. And as you can see here, if we were looking at a scenario of 32 gigs of memory per node, the advantages that Couchbase has in terms of how the active nodes are utilized in each of these scenarios, and the fact that Mongo is using more for its OS and software aspects, means that we have a much larger amount of RAM available for caching and for high-speed data movement. Okay, so that's kind of the fundamental aspects. But then as you scale out, there's additional aspects involved. So another kind of key feature about Couchbase is multi-dimensional scaling. And what this really means is that as our customers begin to scale out an application, they can put different services on different nodes and then configure those nodes with the sort of IaaS and hardware specs they need to ensure they're getting the maximum performance to meet their application's needs, right? So this flexibility, this tuning allows for ensuring high performance, but also helping to lower TCO. So that's kind of, most of the stuff I showed you was related to 3-node systems, right? The BenchAnt stuff and so forth. But what happens when you want to scale out a system? And both, Couchbase and Mongo do support both vertical and horizontal scaling. But let's look at what happens in larger type systems, right? Sorry, next slide. What we're looking at here is some benchmarking done by a company called Alteros. They're an IT firm, and benchmarking is one of the things that they do. And again, we're looking at YCSB benchmark performance, looking at workload A, which is kind of the most common one. It's the one that the bench Ant uses. 50% read, 50% writes. And the difference here versus the kind of the previous data is this is looking at, what happens as the system grows, as we double the nodes and double the records. So you can see here, as we compare for 3 nodes, 6 nodes, 9 nodes, and 18 nodes, how Capella and Couchbase are really continuing to excel even when the system is scaling. Okay. At this point, I'm going to turn it over to Matt. We're going to talk you through a little bit of a demo, and then we'll show a quick video.
Yeah, so this video is, and it will have audio, I'm pretty sure, is meant to kind of help demonstrate how fast Capella can perform. And so this situation is going to generate about 100 million records of data via something called the eventing service in Couchbase. So I think that's a good enough setup. Let's go ahead and start playing that video. I'll go ahead and click that if you don't mind, Tim.
Yeah, go for it.
One of the biggest challenges for app developers is gaining enough meaningful data for functional testing or to stress test their apps at scale. In this demo, I'll show you how to leverage the incredible speed and scale of Couchbase Capella in combination with the eventing service to generate huge volumes of realistic, rich sample data in just a few minutes. We'll begin in the Database Settings tab of Capella, where I have an empty database called Capella Eventing. First, we'll need to create 4 buckets, which our eventing functions will use to generate the sample data. The buckets are start. The corresponding start function looks for changes in this bucket, which kicks off the data generation process. Gen. This bucket is a temporary holding place for the initial set of documents generated by the function. Meta. This bucket is required for all eventing functions to store processing metadata. And data. This bucket will be where the primary data generation happens, so let's give it lots of memory, 100,000 megabytes. Now let's create our eventing functions. Eventing is an amazing feature in Capella that allows you to call JavaScript functions, which are triggered by changes in the data. Eventing is typically used to perform mutations on data or kick off things like alerts when certain types of data changes occur. There are 2 functions in the exercise. I'll import the first function called start. This function looks for changes in the corresponding bucket called start. When a new document is created in the start bucket, the function runs and starts generating initial data in the gen folder based on a data value called count in the document. Let's import the function, then deploy it. Next, we'll import the second function called gen. This function generates complex and realistic JSON document data. As soon as initial documents land in the gen bucket, the gen function detects them, which kicks off another loop to generate the final sample documents in the data bucket. Let's import and deploy the function. Overall, these 2 functions will generate any specified number of documents to the power of 2. I'll go to the start bucket, which is currently empty. I'll create a simple document with no data and a random ID, then save it. This event triggers the start function. With no count value specified, it will only create a single document in the gen bucket, which then goes on to trigger the gen function to create an airline document in the data bucket. To confirm this, we can go to the data bucket, where, sure enough, there is now a new document rich with airline data. Now we can leverage the immense performance of Capella to generate the rest of our sample data. Let's go for 100 million documents. In order to create this high volume of data quickly, we are using the following configurations for our database cluster, which we can see here. I'll modify my first simple doc in the start bucket by adding a count value of 10,000. The eventing functions will pick up the value to generate a massive amount of data in the data bucket. In this case, based on the count value of 10,000 in the starting document, the eventing functions will loop through to create 100 million documents. Now when we go to the data bucket, There are already many documents generated. And finally, we can go to the bucket browser to see the number of documents. At this point, only a few seconds in, we already have nearly 4 million documents in the data bucket. And in just under 3 minutes, we have 100 million new generated sample airline documents, plus the first one we created to test the function. This technique provides a fast way to generate meaningful data for functionality, scale, and performance testing of your applications. To try out generating data with Capella eventing for yourself, get the instructions and JavaScript functions in this GitHub repo.
All right, we're back.
We are back. All right, thank you, Matt, and hopefully you find it interesting, the video interesting to see the how fast Capella can actually run to create a whole bunch of test data. In terms of the kind of differentiation topics, the next one and final one on our list is real-time analytics. So in terms of real-time analytics, I like to think about it as, applications are have always been producing data, right? And the next logical step then is to figure out, what are we going to do with that data? How do we answer questions and improve our business, right? So let's think about this from a Mongo standpoint. If you go to the MongoDB website and you go to their operational analytics page, what it suggests is that to do operational analytics, what you would do is you just run queries and do analysis on the live application data. Now, obviously, you could do this on any database, but really, I think anybody who's going to be doing serious analytics realize that you want to separate your workloads, and this doesn't make a lot of sense. So essentially, they're suggesting then the other alternative is to export to a more relational, traditional analytics store as your other option. But there are challenges with that, right? And whether that be Couchbase or whether that be any NoSQL database, separating your analytics and traditional workloads are important, right? So that way you're not causing issues with your production systems. But the challenges of JSON data, as we know, in its flexible format, doesn't often fit well with traditional relational analytic systems. And why is that? One is the relational rigidity, right? That you've got to predefine your structures. Any changes can cause problems and breakages in the data pipelines, right? And the more data you add into that system and having different JSON documents and different JSON sources adds to that complexity. Additionally, having different teams manage these different workloads means that you have slow analytic turnaround, right? The team that are running the production application that might want to do some analysis are often relying on another team. So how can, what would be a better way to let that team have access to data and do their analysis? And then the fourth point is really about actionability, meaning that what happens when you're doing analysis on your operational data for your application, and you've got some new metrics or some insights that you want to bring back into your application, to run marketing campaigns or to improve the experience to the end user, right? All of these are complex with working with relational analytic systems, and Columnar was designed to overcome that. So Capella Columnar is our next generation of JSON analytics. It's designed really to overcome those challenges with 4 key areas. The first is around zero ETL. So this means that where in a traditional way you'd be taking your data out of your database and converting it into the relational system, Capella Columnar is automatically can process and take your JSON data and translate it into a Columnar analytics ready format, and it's doing that without the need to define a schema in advance. So it's schema on read, right? So this all happens very quickly and very easily. And things like the transformations are happening automatically as well. So like if there's null values or different data formats, that is being handled and you don't need to worry about that. Additionally, we have you can pull in data from multiple sources. So from Capella, from Couchbase Server, MongoDB, in fact, as well as relational files and so forth, really building up that analytic sources. The third key point is around conversational analytics. So with our Capella IQ AI-assisted chatbot, developers can go into Capella or within an IDE and leverage Capella IQ to ask analytic queries and do iterative questions, look at charts and so on. Again, alleviating the burden of working with the analytics or data warehousing team, right? They have a lot more ability to do their analysis. And then finally, Capella Columnar can write back to Couchbase Server or Couchbase Capella, so we can leverage that information and build that better application and so forth. So if we look at it from an architecture standpoint, it kind of looks a little bit like this in our world. In that within Capella, within a single control plane, within a single security layer, you have your traditional server cluster for building your transactional capabilities and search capabilities within your application. And then 0 ETL into Columnar, where we're separating compute and storage, which helps with scalability and performance and lowering TCO. And the data is automatically converted into that Columnar format. As I mentioned, 0 ETL, load data in immediately and continuously. So as documents change, it's automatically brought into Columnar from Couchbase and MongoDB and other sources. The ability to write back to the other application, and then performing analysis with SQL, Capella IQ, and tabular views, which are used by BI tools to access the analytics service here. At this point, I think we have a demo, so I will turn it back over to Matt.
Thank you, Tim. I'm going to stop sharing here, and I will put my screen up. So I think someone is actually asking whether you can ingest Mongo data into Columnar, and in fact, that's what the demo is going to be consisting of, is one of those things. So Columnar is a operational analytic storage engine. It provides workload isolated SQL++ querying of continuously synchronized data. So what we've got here is a Columnar cluster, and I can go ahead and create a link to other data sources. So certainly Couchbase Server, Capella, but also S3, number of file formats there, MSK, and then just about any other data source you can think of through Confluent Cloud / Confluent Platform. So I actually already have a link to MongoDB source here via Kafka. And so if I click on that, you can see I'm actually pulling in comments from a MongoDB database, just one collection. We can certainly pull as many as we want to, but let's just show an example of a query. This is a SQL++ query on the Mongo data that's being ingested. So you can see I've got one result here for Mercedes Tyler and comment in Latin there. So I just want to show that this data is being updated in real time. So I'm going to go ahead and open a tool here called MongoDB Compass. This is a desktop UI tool for Mongo. And I can put in a similar query here. It's not SQL, but it's the proprietary Mongo query language. You can see I get that same piece of data in the Mongo database. So I'm going to make a change, just a minor change to this. I'll change the text message to say hello from the webcast demo, and I'll update that. If we go back over to Columnar, this should be pretty quickly updated. You can see there's the text there. It's been updated based on the change to Mongo, and that's all running through Kafka. Okay, so now we can actually query Mongo and Couchbase Capella and any other data source we have. We can query those together. We can do joins and any sort of data you want to ingest. I want to check out now something I think Tim mentioned already. It's called Capella IQ, and this can help us. Let's go ahead and get rid of some of these old chats here. This can help us generate queries, those queries between all those different data sources. So we're going to start with IQ chat here on just the customers collection. And let's put in a question here. How many customers do I have in the state of California? Now, remember, this is LLM. This is large language model, so it can be kind of finicky sometimes, just in case things go sideways. I'm just covering my bases here. So it's generating a query for us. Let's go ahead and run this query, and we can see, okay, we've got 23,000 customers in California. Okay, let's get a little more complex now. Let's add orders. Yeah, orders to the collection list here and ask another question of IQ. How many orders total did we get from customers in California in October 2023? Okay, so it's generating SQL that's mostly correct here. It's not using the right scope and collection names, but if we run that, it's going to recognize that it made an error and regenerate it. So we'll run the query. And now we get total orders, 86,000. Okay, and I think I know where this is going. If I add in stores here, we'll just do one more relatively complex English sentence here. Calculate the total orders for stores with a store rating higher than 4.5. Show the top 5. And once again, it generates mostly correct SQL. It's stuck now. It thinks that for some reason I'm using a sample scope. So I'm going to go ahead and just modify this by hand to take out that. We don't need that actually. This is what happens with LLMs, I guess. So go ahead and execute that query, and there's the results. Let's go ahead and put this in a bar chart. In fact, we have some basic visualizations built into Capella here. So there are the top 4 stores, top 5 stores, and the number of orders that they have. Now, if we go further, we can actually use a UDF to make analysis even easier. So let's paste in this query here. This is showing pizza orders with demographics. So this is going to include, I think it's just going to include sex with this one. So it's taking a long time to run because there's a lot of orders to execute. But there we go. So you can see the breakdown there by sex and topping and whatnot. Not really granular enough there. It should take in like age, for instance. So let's create a UDF. I'm going to call it age group. This is going to take in a birthday, and then it's going to classify people into different buckets of age groups. So now I'll run that same, once that's I created that function called age group, I'll paste in another version of the function that actually includes age group now. So we'll run that query, and we'll get the results from that with an age group breakdown. Okay. Again, a lot of information to go through. This is pretty common for large analytics queries. They're more complex, and so they take more time. This is actually a benefit to running them in a separate columnar service. Is that this will not affect your operational data load at all. It won't affect your day-to-day customers. So there's the results there. You can see it's broken down. You can keep going in this fashion and break down by different demographics. The last thing I want to demo is writebacks. And analytics databases are important to help break down all these different bits of data, but one key feature that's been missing, long missing in many databases, is the ability of an analytics database to feed its output back into the application so we can quickly apply those insights. So let's start with another UDF here. I'm creating one called distance. And this is a function that's going to find the distance between 2 latitude, longitude points. I also have something I created ahead of time. See if I can actually show this here. Yes, it's a view called delivery days. This is a stored query that acts as a virtual collection. And this tracks delivery destinations and timeframes for stores in the Bay Area for delivery route and on-time performance analysis. So let's actually use that to do some analysis here. So I've got this very long query. I'm not going to make you watch me type this, but it's a complex analytics query. And this is going to show deliveries that were made from a pizza store location that might have been served faster being ordered from a closer store. So here's all the results. These are orders that might have been that could be optimized. It could be done faster. Ordered from the wrong store, routed to the wrong place, or whatever. So, I mean, this query could be useful the day after, the week after. We can get a general idea of how we're doing. But what if we could just incorporate those results directly into our system to get orders rerouted to the right store? So let's go back over to the operational database. This is the actual data that your customers, your website is interacting with operationally. So I've got this collection here called reroutes. And currently there are no records in reroutes. This is a separate cluster for operational data, separate from columnar. But go back over in columnar, we're going to add a little bit of syntax here. This copy at the top, we're going to copy the whole thing. And at the bottom, we'll give that query a name of reroutes results. Then we will copy all those to this reroutes collection via the Capella link. So back to the operational data. So let's go ahead and run that query. And it will go ahead. Oops. I got a syntax there. What did I do? Was I highlighting something? 54. Reroute results, optimize. Oh, I think I have a stray parenthesis there. Sorry about that. So there is going to execute the query, and it's going to put that over in my operational data store. So here's we now have 61 reroutes here live. So our application could see this data and react to it and say, hey, let's actually change this order to a different store so they'll get faster service. So just to sum up, what we've done here is we connected to a Mongo database. We've ingested data automatically. We've queried it with SQL, and we can write the results back to the operational database. I'm going to hand it back over to Tim.
All righty. Let's, so 1 second, hold on. We were here. Great. Thank you, Matt. All right. So we've covered all 5 of the big major differences. Talking about mobile, talking about performance, talking about query language and data organization, talking about analytics. So I think we've kind of highlighted the major key points. And then kind of just summing up, just a couple more slides. So really, Couchbase as a platform designed for teams of all sizes, startups to large enterprises, focused on making sure that customers' applications have the performance that they need at scale for their important applications, and ensuring they have the flexibility with the familiarity of SQL, which is such a big part of the database world. How can you get started if you haven't signed up yet for Capella free tier? You can do that today. This is free forever. You sign up, you get access to the core services that are available, including Capella IQ, including vector search and so forth. Within Capella, within the free tier, there's a playground which has some information about SQL++. You can learn more about that. There's tutorials on the website in our developer zone, and you should definitely try out Capella IQ. All right. More resources. I highlighted this at the beginning. In the Docs tab over here, you can download this deck as a PDF. It has links to the Alteros report, a Couchbase versus Mongo, links to Benchant that we highlighted, YCSB benchmarking, and so forth. How that's the webinar on how you might run this yourself. The video on Realm to mobile if you want to learn more about how you might make that move. And then some links to some of the demos that Matt has that we've shown, some mobile demos as well. So with that, we'll wrap it up. Matt, were there any questions you saw in there that I know we've been trying to answer questions along as we've gone along the whole time? I don't know if there was anything else that you saw in this last little bit.
There are tons of questions. Some of them need more of a follow-up than just an answer on chat. But do you think we could try that mobile vector demo again? Maybe see if we can get audio over that. Just talk through it real quick.
Yes, it doesn't. I mean, the video itself doesn't have audio, right. So I don't know if I think we got muted when we were playing the video. But let me see if I can share.
I was able to talk over it. I think it just muted me automatically, but I could talk over it once it got started.
Okay. So I mean, essentially, I'll explain it again. Essentially, it's a small little application designed to emulate kind of a retail environment where that application is on a mobile device, right? So if we were live, I would show this in front of you on my phone. And that mobile application could be on an iPad and so forth. And the way it's designed is that it's leveraging the camera so that as it's scanning an object, in this case, images of fruit and vegetables and other things, it is taking that photo. It is using Apple Vision's framework, and it is then taking that image, it is converting it on the fly in real time to a vector, and it is then doing a vector search within the Couchbase Lite database where the product catalog would be stored. Once it has the match, it is then adding that item to the retail basket. So that's really what you'll see here. I don't know if were you able to hear me at that point? I can't hear you now, Matt. All right, Matt, I can't hear you. I don't know if you can hear me. I think we're just going to wrap it up. Yeah, it says Matt is muted. So sorry, Matt. But I think we'll wrap it up here. And for any more of the advanced questions that we didn't get to, we will get to it. Can this work on Android is one of the questions. That app that you can see the link to down below at the bottom item, it's a simple app that we built on Apple, but does Couchbase Lite work on Android 100%? It's just this little demo does not. But all right, with that, we want to say thank you to everyone for joining. This has been, hopefully you've enjoyed it. Thank you for all the questions. We appreciate it. So thank you very much.